In this demonstration, I'll show you how to rationalize a denominator. To rationalize a denominator means to somehow get rid of the square root that is located in the denominator position. We usually get rid of the square root in the denominator position because by convention it shouldn't be there. If you ever run into a situation like this where you have a square root, that is, the index is a 2, it is the easiest type to rationalize. Now here's what you do. You multiply the top and the bottom by the term at the bottom. And if you do that, you end up with the following. At the top, you end up with 4 times the square root of x, this multiplied to this. And at the bottom, you end up with the square root of x times the square root of x. And recall, if you multiply two square roots, for instance, the square root of a times the square root of a, you end up with simply a. So in this case, the square root of x times this is equal to x, and there you have it. That is how to rationalize this expression. Let's move on to another question. In this case, you have to rationalize the following. Once again, the term at the bottom is a square root. So to rationalize this, we multiply the top and the bottom by 3x. If we do that, we end up with the following. At the top, the numerator, we get the square root of 3x, and at the bottom, we end up with simply 3x. And there you have it. That is how you rationalize this expression. Let's move on to one that's a little bit more complicated. In this case, we have 2y divided by 4 times the third root of x. Now, this is more complicated because you can't simply multiply the top and the bottom by the third root of x. It doesn't work that way. Instead, you have to ask yourself, what can I multiply the third root of x such that this term, known as the radicand, is a perfect third root? What you have to multiply this term by is the third root of x to the power of 2. Now the reason why that works is because both of these terms are a third root. Therefore, we can house them underneath one root. This radicand times this radicand, x times x to the power of 2, is x to the power of 3. X to the power of 3 is a perfect cube root. So what we're going to do is we're going to multiply the top and the bottom by the third root of x to the power of 2. And when we do that, we end up with the following. The bottom part becomes 4 times the third root of x to the power of 3, and the top becomes 2y, the third root of x to the power of 2. Now this is really messy, but keep in mind that this right here will reduce to simply x. So what we end up with is 2 times y times the third root of x to the power of 2 over 4 times x. That is how you rationalize the expression. Let's move on to the next one. In this case, we have a similar tricky situation. We have to find something that will multiply to the fifth root of x to the power of 2 such that the radicand ends up becoming a perfect fifth root. Now the only thing I can think of is the fifth root of x to the power of 3, because if you multiply this term by the fifth root of x to the power of 3, you end up with the fifth root of x to the power of 5. Henceforth, this reduces to x. So we're going to do this to the top and to the bottom. The fifth root of x to the power of 3 and the fifth root of x to the power of 3. And we end up with 2y times the fifth root of x to the power of 3 over 4. Recall, we multiplied them here already, and it reduced down to x, 4 times x. So there you have it. That is how you rationalize the denominator. If you have any more questions related to this video, please comment below. If you found this video helpful, like it, and if you still have more questions, use our website at biology-forums.com. It is the link that is shown to the bottom right of this video. See you soon.